Hello, Year 11 Extension 1 students. Unfortunately, I'm stuck in isolation for the next week, so the next two lessons I'm going to try and do videos so that you can watch it in your own time and just have a go at the questions in the textbook that I set. So in this video, I'm going to continue with our topic of combinatorics. This is on page 53. If there's any questions, once again, email me. I'm more than happy to try and answer, or send a message on the Microsoft Teams, and I'll try and answer you there as well. So here we are on page 53. Over the last couple of lessons, we were looking at permutations. How many ways can we order a group of things in a line if there's identical elements? Or most recently, we were looking at what happens if we want to order things around in a circle. And so with those, we fixed one and then we fixed one person in a circle and then moved everyone around that. We're now moving on to the next section, which is called combinations. Now, there's a definition here of what makes a combination different from a permutation. So a combination is once again, is very similar. It is a grouping of objects. So we're once again looking at groups of objects. But in this case, and this is an important part with combinations, is that the order is irrelevant. Sometimes this is called unordered selections. And so what we're imagining here is what happens if we want to select a group, but it doesn't matter what order they come in. When we're looking at permutations, when we selected 5 people, we also ordered them. We said, for example, we wanted to order 5 people in a line. And so we said that if we wanted to order 5 people in a line, let's say there was 10 people and we wanted to order them in a line. Well, the first spot, 5 of them in a line. So the first spot would be 10, second one would be 9, there'll be 8, there'll be 7, and then there'll be 6 possible spots, possible people to put in the first line. So this is a permutation. And so this was 10p5. We've got 10 people and we're picking out of that group 5 of them. With a combination, however, it doesn't matter which of what 5 it doesn't matter the order that they come in. We just want to see what group of 5. So the way I like to think of it is a permutation is like we're ordering them in a line. A combination is like we're selecting a team of 5. It doesn't matter what order they come in. We could have Andrew, Bob, Chris, Dennis, and then Edith. But you can have it in the reverse order and they'd be the exact same group. So like here, in this case, A, B, C, D, E is the exact same as E, D, C, B, A. We just want that group of A, B, C, D, E. And so that's how combinations are different from permutations. And so it's sometimes called unordered selections. And so there's a few key words. If you hear the word group, committee, or team, notice with all of those types of things, it doesn't matter what order these people come in. If they say specifically, we want a committee with a president, vice president, treasurer, and so on, yeah, sure, there's a bit of order there and you need to use permutations. But if you just want to find a team or a group, we don't need to actually figure out how many ways we can order them. And so here, this is similar to a permutation, but we divide by the number of ways to order the selection. And so here, what we do is if we want to figure out what n choose r is, so this is npr we said was n pick r, ncr is n choose r. We're choosing from n possible elements r things. And so here, commence with npr, n pick r, and choose, i.e. choosing r objects from n objects. The number of combinations is given by removing the repeated cases. So just like I said earlier, if I had A, B, C, D, E, E, D, C, B, A is just a repeated case of that exact same thing. And so when we try to find n choose r, the formula that we use is npr divided by r factorial. And so here, in this particular case, it's actually written as n factorial over r factorial bracket n minus r factorial. And so this is actually a formula that we can use to help us figure out the number of ways of choosing a thing. So let's have a look at a particular example of this. Find how many possible combinations there are if from a group of 10 people, 2 are chosen and 8 people are chosen. So let's just use this formula. So NCR is equal to n factorial over r factorial n r minus n minus r factorial. So just remember, n is the number of possible things that we can choose from. So in this case, how many possible things can we choose from? Well, in this particular example, there are 10 people that we can choose from. So for the first one, A, if I want to choose 2 people, my pen's not working. A, I want to choose 2 people from that 10. That's just going to be 10 choose 2. And so let's just chuck this in the formula. So this is 10 factorial over 2 factorial times 10 minus 2 factorial. So when I substituted n is equal to 10 and r is equal to 2, I get this formula. So this is 10 factorial over 2 factorial times 8 factorial. And from factorial notation, we can actually cancel out a bit of the 10 factorial. So 10 factorial actually includes 8 factorial. So here, this will cancel out. And so we have 10 times 9 left over. And the 2 will actually cancel out with 10. So we have 5. So this gives me 45. Okay, part B. Now we've chosen 2 people. Now let's choose 8 people. So here this is going to be 10 choose 8. And so this is going to be 10 factorial over 8 factorial times 10 minus 8 factorial. And so this is going to be 10 factorial over 8 factorial times 2 factorial. And here hopefully you're already going to see something. You're going to notice that, hang on, actually, isn't this the exact same thing as this thing before, as this answer before? And this is indeed the case. This is actually going to give me 45 in the end as well. So why is that the case? Well, if you think of it in this way, if I've chosen 2 people, how many people are left in that group? Well, if I've chosen 2 people, that means that there are actually going to be 8 people left over. So even though I haven't actually chosen that 8, I've kind of left them as unchosen. And by doing the opposite, it's kind of like I've actually you can kind of think of it as, by choosing my 2, I've actually chosen the 8 that I'm not going to select. So here, there's a bit of a property with this choose note, this n choose r thing. There's a bit of symmetry. If I want to find n choose r, that's actually the same as n choose n minus r. So notice here, 2 and 8, when I add them up, they're going to give me 10. So if I'm choosing the 2, that's the same as choosing the 8 that aren't selected. And so that's a really nifty little property about our choosing our combination thing here. Okay, so how do we do this, and how do we use this in for a few questions? So over the page, there's an example which highlights the difference between a few of our things. So let's have a look at this example here. This is from the 1995 3-unit HSC exam. So a security lock has 8 buttons labeled as shown. Each person using the lock is given a 3-letter code. So we've got the letters A to H, and they are using a 3-letter code. Now, let's have a look at the examples here. Let's look at I. How many different codes are possible if letters can be repeated and their order is important? So 2 things to note here. We want to figure out how many codes are made if the letters can be repeated and the order is important. So this is a ordered selection. So let me make a note here. So ordered selection. So the order does matter, which is not the combination thing that we've looked at. And we have repetition. So if we have repetition, let's just draw this out. So we have a 3-letter code. 1, oh, that's not the button I wanted to press. 2 and 3. And with our repeated, so that's our order selection for 3 letters. So in the first spot, how many possible choices can I make? Well, there's 8 letters, so I'm going to put an 8 here. Okay, in the second spot, how many choices can I make? Well, because I can repeat any of these elements, I can use, if I picked A for the first spot, I can use A again. That means that there's actually 8 possible choices for the next spot. And hopefully you can see as well, it's going to be 8 choices in the third spot. And so if I want to figure out how many ordered selections with repetition there is, all I need to do is just multiply 3. This is 8 times 8 times 8, or just 8 cubed. So here, we've got an ordered selection with repetition, and that just gives me 8 cubed. Let's just figure out a number for this. So 8 cubed, that gives me 512. Okay. That's a first example. Let's have a look at the second example. Now, how's the second example different? Let's have a read of it. How many different codes is possible if the letters cannot be repeated? Okay, this is where it's a little bit different from the first one, and the order is important. So here, let's just note a few things. Notice here, compared to the first one, the order is still important. The order that the letters happen is still important. ABC is going to be different to CBA. But the thing that makes it different is that in this second example, the letters cannot be repeated. So let's just make a note here. So this is a ordered selection. So this is once again a permutation. But here, repetition is not allowed without repetition. Let me just make a note here. Without repetition. So let's just draw up our three possible letters. So 1, 2, 3. In the first spot, how many possible letters can we choose from? Well, there's 8 possible letters, so I can choose 8 in the first spot. How about the second spot? Well, in the first spot, I've actually selected one letter. And so that means in the second spot, one letter is actually gone from the selection. I can't use one of the letters. So let's say in the first spot I have A. That means I can't use A in the second one. So how many possible options are there? Well, there's 7 letters remaining. So this next one's going to be 7. And after the second spot, I removed 2 letters. So the third one is going to be 6. And so here, the total possible outcomes is 8 times 7 times 6. This is actually our 8 possible choices. Pick 3. So out of our 8, we picked 3 possible choices. And so we can chuck this again in our calculator. So 8, shift. So the pick is this little button above the times. Pick 3, and that'll give me 336. So here, with our order selection, without repetition, there's 336 possible ways of doing this. Okay, now let's have a look at the third option. So the third option. Now suppose that the lock operates by holding down 3 buttons together, so that the order is not important. So here, this is where this one is different from the previous 2. Notice the previous 2, the order mattered. ABC was different to CBA. In this last case, the order is not important. And this is where our combinations comes in. So here, unordered selection. And so with this particular case, what we need to do is use our combinations. Well, there's 8 possible letters, and I'm going to choose 3 of them. And so I'm going to go into my calculator, and I'm going to put this in, 8, shift, and the choose is the button above the divide, C3, and we end up getting 56 possible outcomes here. Okay, so that's the difference between the things that we've looked at so far. The first example, we had ordered selection where there was repetition allowed. The second one, there was ordered selection without repetition, so elements could be used again. And the final one, it was unordered. This combination concept that we've just introduced, where it doesn't matter what order you select them in, as long as you've got the same 3 letters. So ABC is going to be the same as CBA. As long as we press them all down at the same time, they're going to be the exact same. So that's how these 3 things are a little bit different from each other. Okay, so let's go over the page and have a go at a few examples. So here, first example. A committee of 5 is to be chosen from 6 men and 8 women. Find how many committees are possible if. Okay, so here we're going to be using, notice here it's the word committees. It doesn't matter which order the committee is selected. It doesn't matter if it's a boy chosen first and a girl chosen and a boy chosen again and so on. We just want to select a committee of 5. So for these, we're going to be choosing 5 possible things. We're going to be selecting 5 possible things. Now we're selecting from 6 men, 8 women. So altogether we have 14 people. That will help us later on to figure this out. So let's have a look at the examples here. So the first one is if there's no restriction. So it doesn't matter if we have to have a certain number of men or a certain number of women, no restrictions. So how many possible ways can we do this? Well, there are 14 people. So I'm going to have 14, and out of them, because it's a committee, it doesn't matter what order we select them in. It's going to be 14 choose. How many people are we choosing? We're selecting 5 people. So it's going to be 14 choose 5. I can chuck this in my calculator. 14 choose 5. And that'll give me 2002. So there's 2002 different ways of selecting a committee of 5 people from these 6 men and 8 women. Okay, cool. Let's have a look at part B. Part B, all the members are to be female. Now, if we want all the members to be female, that means that we actually need to change a few things. And it means we either need to change the number of things that we can select from or the number of things that we select. Or actually a combination of both. So let's think about this one. If all the members are to be female, what does that change about my choice? Well, we're still selecting 5 people. That's fine. But it means that the pool that we're selecting from is going to be different. Originally, we were selecting from 14 people, but the 14 people here includes the 6 men. So with this second example, if we want all the members to be female, that means, so let me just have the notation, NCR, N must equal to the 8 women. The number of people that we choose from, the possible pool that we choose from, has to be from the 8 women. So here I'm going to have 8 choose 5. We're still selecting 5 people. It's going to be from the 8 women there. So it's going to be 8 choose 5, and that gives me 56. Okay, let's have a look at the next example. The next one, C. All the members are to be male. Now this is just the opposite case. So instead of having n is equal to 8 women, we're going to be selecting it from the 6 men. So here this is going to be 6 choose 5, and so we're going to get 6 choose 5. That's 6. So there's 6 possible ways to select the committee out of the men. Okay, D. There are exactly 2 men. Now, if there are exactly 2 men, what does that mean is happening in my committee? If there is exactly 2 men, we have 2 men, how many women are remaining? Oh, how many people are remaining in the remaining spots? Well, that means we have 2 men and 3 women, right? Okay. So what this means is then I just select the 2 men and I select the 3 women. So how do I do that? Well, for the 2 men, how many men can we select from? Well, for the 2 men, we have 6 possible men, and we're choosing from them 2. How about the women? Well, we've got 8 women, and we're selecting 3, so it's going to be 8 women. We're choosing 3. And all I need to do between the 2 of them is just multiply. So let me just make a note here. So this is selecting 2 men from the 6, and then this second part is selecting 3 women from the 8. And so here, this is going to be 6 choose 2 times 8. Oop, I'm pressing all the buttons I shouldn't be pressing. Choose 3. There we go. So that means there's 840 possible selections that we can make for this one here. Okay. Part E. Now there's 4 women and 1 man. Hopefully you can see that it's quite similar to this one. If there's 4 women and 1 man, we're just going to have, for this one, well, we're going to select the 4 women. So there's 8 possible women to choose from. We're going to select 4, and we're going to multiply that by, well, for the 1 man, there's 5 possible men, and we're choosing 1. And so here we can chuck this straight into our calculator. We could also do this arithmetically. So we could go 8 choose 4 is just 8 factorial over 4 factorial times 8 minus 4, which is 4 factorial, times 5 factorial over 1 factorial times 5 minus 1 factorial, which is 4 factorial. And so we can actually start to cancel stuff out. So here, that's 5 factorial, we'll cancel out with this, so we're left with 5. This 4 factorial will cancel out with the 8 factorial, so we're going to have 8 times 7 times 6 times 5. And the 4 factorial, so that's going to be 4 times 3 times 2 times 1. That's actually going to cancel out with the, so the 4s and the 2 will cancel out with the 8. 3 will cancel out with the 6, and we have left with 2. And so here, this just becomes 7 times 2 times 5 times 5, which I believe will give me 350. So we can check that with a calculator. 8 choose 4 times 5 choose 1, which gives me 350 as I predicted. So here we're going to be selecting 3 women from the 8, and this one is we're choosing the 1 man from the 5. Okay, so that's for these first couple of examples. Let's have a look at the next one. The next one, F, if there is to be a majority of women. Now here we don't specify that we have to have 1 man or 2 men or exact number, we just want a majority. What does it mean for us to have a majority? Well, actually there's a few ways that you could do this. Well, if you want a majority, that just means you have, well, if there's a group of 5, we have to have 3 or more women. So you can have 3 women and 1 man, or 2 men, 4 women and 1 man, or 5 women and no men. So that's one way that we can do it. So we can just find how many are in each one of these cases and add them all together. Luckily for us, we've actually found all of these. So if you have a look, 3 women and 2 men, that's actually the exact same question as part D. 4 women and 1 man is exactly the same as part E. And 5 women and no men, well, that's just all female, which is actually part B. And so we can add all the answers from part D, B, D, and E all together. So let me just write that down for F. So majority women, and let's actually write it in combination notation. So the first one is 8 women choose 3 times 5 men choose 2. So this is the 3 women, 2 men case. And we're going to add on top of that 8 women choose 2 times 5 men choose 1. Oh, choose 4, I mean. So this is 4 women, 1 man. And the final case was 8 women choose 5, which is the 5 women case. And so we can just add BDE together. So that's 56 plus 840 plus 350, which I believe gives you 1,246, I believe. Let me just check that with a calculator. So 56 plus 840 plus 350, could be off by 1. Yeah, 1,246. There we go. Okay. So when we are looking at these cases where they're the majority, you just want to be able to figure out what cases there are available. Okay, so G. G is where we start to get a little bit trickier. Now here, if for part G, a particular man must be included. Now, if a particular man must be included, that means that we've already put this man in there. What happens to the rest of the group? Are we still selecting 5 people, and are there still 14 people that we're selecting from? Well, if a particular man must be included, what this means is, so I'm going to write here, one particular man included. Ugh, I can't even spell particular. That's okay, I'm not an English teacher. One particular included. Well, there's no restrictions on the rest of the group. What does this mean? Well, actually, if there's one particular man included, they're removed from the pool of possible people that we're selecting from. So N, instead of being 14, because there was 14 people, 6 men and 8 women, it now becomes 13 people that we're selecting from. Okay? The other thing is then, well, how many people are we selecting from this group? If this one particular man has to be included, we've already got a spot given to him, so there's actually only 4 spots remaining. And so with this all together, that means that we're going to get 13 choose 4. So with this one particular man being included, that has reduced the possible pool that we're selecting from, or the possible elements that we can choose from, and also the number of spots that we are choosing. So here, this answer, 13 choose 4. So there's 13 people because we've reduced it by 1, and there's 4 spots available because that man has also taken the spot. So let's put this in, 13 choose 4. And so here we get 715 ways of doing this. Okay, so that's our next example here with the 4 selecting that, including that one particular man. There's now one final example, and I've ran out of space, so I'm going to do it up the top here. Okay, H. A particular man must not be included. Okay, so one man excluded. What does this mean to my pool? Well, if this one man is excluded, then let's just use the logic and let's think through what happens to the pool of possible applicants that we're choosing from, and also the number of spots that there are. What happens to the pool of applicants? Well, originally there was 14. If we exclude this one particular man, well, that means that there's going to be one less person that we're choosing from. So here, like the previous example, there's 13 people that we are selecting from. How about the number of spots that we're selecting? Well, if this one man is to be excluded, that doesn't affect the number of spots. He's not being put into the committee already, so that means that there's still 5 possible spots to select. And so putting this all together, we want 13 choose 5. And so I'm going to put this in my calculator, 13 choose, wrong button, choose 5. And so here we get 1,287. So notice here with these 2 examples, so maybe I'll move it down so we can actually see this next to each other. Try that again. There we go. Okay. And it's going to be a little bit hard to see. I apologize. So with these two examples, the first in G, when one man had to be included, that affected both N, so the number of things that we were choosing from, and also the number of spots R that were available because that one man took up the spot. But in the following example, where the one man had to be excluded, that only affected N because that meant that one less person was to be selected. That didn't affect how many possible spots there were because that man wasn't taking up any of the spots. So that's for this set of examples here. If you need to go back and pause at any point, you feel free to do so. You can control the video and do whatever you want with it. I'm going to move on to the next example here. Okay, so let's have a look at here, and there's actually answers underneath. We're going to try and have a go at these without looking at those answers. So let's have a look at example 70. 10 people meet to play doubles tennis. So here, 10 people are meeting together to play tennis. So that means that most likely that N, the number of people that we're selecting from, is going to be 10. But sometimes that might change with each question. So let's be careful and have a look here. In how many ways can 4 people be selected from this group to play the first game? Ignore the subsequent organization to pair. So if you remember, so doubles tennis, you've got doubles, you've got like Nick Kyrgios and his mate Kokonakis. And then on the other end, you've got 2 other blokes, the 2 other Australian dudes who I did not pay attention to because they had boring names. So we're selecting, when we're playing a game of doubles tennis, we are selecting 4 people to go on the court at any one time. So let's have a look at part A. How many ways can 4 people be selected in this group to play the first game? Are there any restrictions on this group? Doesn't seem like there is any restriction. So here, all we're going to do is take our 10 people and we're going to choose out of them 4 to play on the court. It doesn't mention any particular order they have to go on the court in. It doesn't mention who needs to go where. And so we're just selecting 4 people, any group of 4. So that's going to be 10 choose 4. So I can put this in my calculator. Actually, we can leave it in this choose notation as well. That's totally fine too. That's what the answers have done. Okay, great. Okay, so let's have a look at this next example. So here, part B. How many of these ways will include Maria and exclude Alex? So here we want to include Maria and exclude Alex. Okay. So let's just do each part and do each of these conditions in turn. So here, let's see what happens when we include Maria. So firstly, what happens when we include Maria? What happens to the number of people that we choose from and the number of spots? Well, let me just draw it over here. So if I had 4 spots, if I choose Maria and include her in one of the spots, that means that there's 3 spots remaining. So here, R becomes equal to 3. We only have 3 spots remaining and available. How about N? Now we already started with 10 people playing. If Maria is included, that means that we've already got 1 spot taken. So that means that there's only 9 people available to choose from. So here, when we include someone with combinations, that means we reduce the number of possible applicants that we're choosing from, so the number of people in this case, and the number of spots also decreases. Now, we're moving on from here. So here, if we exclude Alex, what happens to the number of spots? Well, there's still 3 spots remaining. That doesn't change. 3 spots remaining. But if before there were only 9 people, if we exclude Alex, that means that there's 1 less person that we can choose from. And so here, that means that there's going to be 8 people remaining. And so as our final answer, this is going to be 8 people choose 3. When we include Maria, we've taken 1 person out of the pool, but also gotten rid of one of the spots in my doubles tennis, game. When we exclude Alex, we remove another person from our pool of people to choose from, but it doesn't affect anyone on the court because Alex isn't included on the field. So that's how we do this next example, where we include someone and exclude another. Okay, let's have a look at part C. If there are 4 women and 6 men, how many ways can 2 men and 2 women be chosen for this game? Doesn't matter what order happens. So let's just deal with each one of these separately. So we want to select 2 men for the game. How many ways can we do this? Well, how many men are there? There are 6 men. So I'm going to have 6 men and I'm choosing from them 2 of them. Okay? Then on top of that, we need to multiply this with how many ways that we can choose the women. So there are 4 women, and we need to choose 2 of them. So we're going to be 4 choose 2. So here, let me just make a note. So this is for the 6 men, and we're selecting 2. And for this one, we've got 4 women, and we're selecting 2. Okay. And so the answers also tell me that this is equal to 90. So let's leave that for now. Okay. And we'll leave it as that for now. F. Oh, D. Why did I think that was an E? D. Okay, the last one. Again with the 4 women and 6 men. So here we've got 4 women, 6 men. How many ways will women be in the majority? Well, let's think about it. What ways can we get women in the majority? If there's 4 people on the court, the only ways for women to have a majority is if we have 3 women and 1 man, or for all 4 women on the court. So how many ways can we do this? Let's deal with the first case. So 3 women and 1 man. So if there was 3 women and 1 man, let's select the 3 women first. So how many women are there? There's 4 women, and we're choosing from 3. And then for the 1 man, we need to multiply that with 6 men, and we're choosing 1. Okay, so that's our first case of 3 women and 1 man. So right here, this is the 3 women and 1 man case. Then on top of that, we need to get the case where there's 4 women. So there's 4 women, and we're going to choose 4 out of them. And so here, all we need to do between the 2 of them is just add them together. Now, a quick note, 4 choose 4. If I've got 4 things and I want to choose all 4 of them, how many ways can I do this? Well, it's always going to be 1. If I want to choose n items and from n things, there's only 1 way to choose. I have to choose all 4 of them, and there's only 1 way to do that. And so here, this gives us that final answer of, and I believe the answer will be 25 indeed. Okay, cool. Hopefully that makes sense. Let's move on to the next question. I will do maybe a couple more questions, and I'll leave you guys to have a go at a few questions, and I'll have a go at a few more of these questions in the following video. So let's have a look at the next example here. Okay, here we go. We have a multiple choice question from a Catholic school's examination. From 6 girls and 4 boys, a committee of 3 girls and 2 boys is to be chosen. How many different committees can be chosen? Okay, we can do this in a few parts. So here we've got 6 girls and 4 boys. And we want a committee where there are 3 girls and 2 boys to be chosen. So let's deal with the girls' cases and then the boys' cases separate. In the girls and then the boys. So if there's 6 girls and we want to select 3 of them, how many ways can we do that? Well, that is just 6 choose 3. I've got 6 girls and I'm choosing 3. So here I'll maybe put this in yellow. So 6 girls choosing 3 girls out of them. Okay. Then on top of that, I've got the boys. So there's 4 boys and I need to choose out of them how many? 2 boys. So this is my 4 boys and I want to choose 2. And all I need to do with these 2 numbers is just multiply. They're not 2 separate cases. They're happening at the same time to make that one committee. And so I'm just going to go 6 choose 3 times 4 choose 2. And we get 120, which happens to be B. So here, when we've got things that make up the same committee, we multiply them. If we've got different cases, however, so here in this particular example, so to make a note about when we add and when we multiply, in this example, we can't have 4 women happening at the same time as 3 women and 1 man. So that's why there's 2 separate cases. But here, because the committee is made up of 3 girls and 2 boys at the same time, it's not a committee where there's 3 girls and then there's a committee where there's 2 boys. We multiply the 2 because they make that one case altogether. Okay. Hopefully that makes sense. Over the page, I'm going to go through. Let's see which ones I'm going to do. Yeah. Let's see how many I may do. I'm going to go through the next 2 pages and then I'll give you guys, and we'll stop the video there. Okay, once again, we've got another multiple choice question, which makes this really nice. Okay, so a math department consists of 5 female and 5 male teachers. So we've got 10 people altogether. How many committees of 3 teachers can be chosen which contain at least 1 female and 1 male? So let's just think about this condition here. So we've got 5 female, 5 male, and we want to make a committee of 3 teachers. Each committee must contain at least 1 female and 1 male. Okay, so how many ways can we do this? So let's think of the cases. So there's going to be one case, because there's only 3 teachers. We need 1 male, 1 female. So that means there's only just 1 spot remaining. So let's think about that. So we've got 1 female, 1 male, and we've either got the case where we can actually end up with 2 females and 1 male, or 2 males and 1 female. So let's just do the math for this. So 2 females and 1 male. How many ways can we do this? Well, let's select the females. How many females are there? There's 5 females, and we're choosing 2 out of them. Then for the 1 male, how many ways can we do that? Well, there's 5 males, and we're choosing 1 of them. And so for the first case, where we've got 2 females and 1 male, we've got 5 choose 2 times 5 choose 1. Okay, let's have a look at the second case, where we've got 2 males and 1 females. Let's select 2 males. So we've got 5 males, and we're choosing 2 for the 2 males. And then we've also got 1 female, so 5 choose 1. Notice here, because this happens to be symmetrical, there's 5 females and 5 males. They just both happen to be the same. And with those 2 numbers, what do we need to do? Well, we just need to add them up. And so I'm going to put this in my calculator. I'm actually going to do it a lot quicker. I'm going to do 2 times of 5 choose 2 times 5 choose 1. And so we end up getting 100. So this gives me a 100. And so here, this is 100 ways of doing this. Okay. Hopefully that was helpful, that one. That one hopefully was pretty straightforward. Let's have a look at this particular next question. What is the number of combinations of the letters of the words equation taken 4 at a time without repetition? So here, without repetition, also very, helpful for us to help figure out what combinations we want. So, this helps us realize that this is actually a combination. It's just without repetition. First of all, it's combination and without repetition. Quite nice for us. Let me just take all of that back. Okay, so how many letters are there in the word equation? So we've got 1, 2, 3, 4, 5, 6, 7, 8. There's 8 letters in equation. So how many ways can we make a combination of 4 letters? Well, it's just going to be 8 choose 4. We're selecting 4 possible letters out of the 8 there. Okay, part B. How many contains 4 vowels? Now let's see how many vowels there are in equation. So there's 1, 2, 3, 4, 5. Okay, so there's 5 letters, which contains 5 vowels in my word equation. So we want to create a combination of 4 vowels. How many ways can I do that? Well, there's only 5 vowels available, so I'm going to have 5 choose 4. Because I want to ensure that I'm only selecting out of the vowels. If I want my word to contain 4 vowels, I do 5 choose 4. Okay, the last one, part C. Must contain letter Q. So contains Q. This is very much the same as those questions where we did include something. So if we include Q, what does that mean to my number? What does that mean to N? And what does that mean to R? So N, originally there were 8 letters. If I've selected Q, that means that there are 7 letters remaining. Now, I'm once again making a selection of 4 letters. If I've selected Q, how many letters am I choosing from? Well, in this case, I've already selected 1, so there's only 3 spots remaining. And so for this example, we've got 7 choose 3. 7 choose 3. And that's how we select this particular case. Now, this video has gone on for quite a bit. It's been roughly 40 minutes. So I'm going to let you guys actually have a go at a few questions on your own. I'll post up which questions for you to do. But until next lesson, Year 11s, I hope you guys are doing well. And I'll see you guys via video again for our next lesson for this week. Bye.